Welcome to this video where we explain our project, a moisture-based automatic plant watering system. It's a smart solution for keeping plants healthy in hostels or homes, especially when regular watering is impossible. The system waters plants automatically when the soil is dry and stops when it's sufficient. No manual checking is required. And it also offers real-time monitoring via Bluetooth.
Like hostels, students are usually busy and often forget to water plants. This neglect leads to dry, unhealthy plants and over dead ones. To solve this, we created a fully automated system that monitors both moisture in the soil and water availability in the tank, then takes action accordingly, all without human
Look
intervention.
at the key components of our project. First, we have the Arduino Uno, which processes all sensor data and controls the output actions. Then, we have the soil moisture detector, which detects if the soil is wet or dry by giving an analog voltage signal based on the moisture content. Then, we have the op-amp comparator. We use the op-amp to compare two voltages, one from the moisture sensor and one from fixed reference voltage. So when the soil is dry, the sensor voltage drops below the reference level and it sends a high signal to the Arduino telling it that the plant needs water.
Sensor, which is mounted on the top of the tank, checks the water level using sound pulses. It helps us prevent the pump from running when the tank is empty. Here is the Bluetooth ES116 Bluetooth module used to transmit the moisture and water level data to a phone. You can monitor the plant status from anywhere using a Bluetooth terminal app. Now here is a buzzer LED. Here is a LED connected to an output pin to alert the user when water in the tank is low. Now here is some resistor which is used as a voltage divider. This is made value of resistor are 10 kilo ohm and 20 kilo ohm, and we reduce the 5 volts Arduino signal to 3.3 volt before sending to Bluetooth model's RX pin, keeping it safe from damage. Now I will explain the mechanism of the system. Now here you can see soil is dry and we put a sensor in it, and here is sufficient water level, so water should flow from a tank to the plant. Let's see. Now you can see now water is wet. That's why here pump stops running. Now I will show you readings through Bluetooth terminal app. Look, here is pump is off. Now I will take out this moisture sensor. Now you can see again here is a reading of the pump. Here is pump is on and water is also flowing through water tank to the plant.
And we can see the pump on the Bluetooth terminal. In the working of a project, the soil moisture sensor sends a voltage to the non-inverting input of the op-amp, and a reference voltage is sent to the inverting input of the op-amp using a voltage divider, and the op-amp compares these two. So if the soil is wet, then the sensor voltage is higher than the reference voltage of 2.5 volts. So the op-amp output is low and nothing happens. If the soil is dry, the sensor voltage is lower than the reference voltage, and the op-amp outputs high, which is sent to the digital pin D2 on the Arduino. Simultaneously, the ultrasonic sensor checks the distance from the top of the tank to the water surface. If the water level is above 5 cm and the soil is dry, then the Arduino turns on digital pin D7, which activates the relay. So the relay then activates the 9 volt powered pump, drawing water from the tank and into the plant. If the water level is low, such as now, the pump stays off and the LED lights up to notify the user.
This feature adds a layer of smart monitoring. We use a software serial on pins D10 and D11 to communicate with the ES0 Bluetooth module. After every few seconds, Arduino sends the data like moisture level and water level to a phone. You can see here. So even if you are not near the plant, you can easily check its status remotely using any Bluetooth terminal app. This real-time data transmission is really handy for maintaining plants without minimal effort.
Tested our system thoroughly, as we already demonstrated before. When it is in dry soil, then water comes out and from the tank and waters it, and if it is in air like now, then it gets activated and water comes out of it. Also, when the ultrasonic sensor doesn't detect the water level, it turns on the LED light. So on the phone, we saw live updates of both the sensor readings, confirming the reliability of the system.
This project is a simple yet a powerful solution to a very common problem. It combines the electronics, sensors, and logic to care for plants automatically. With the future improvements like weather detection, cloud connectivity, this can evolve into a full-fledged smart garden system. For now, it's an efficient and affordable system that makes life greener and easier. Thank you.